Can numbers own houses? Real numbers can. They actually have a lot of properties. Welcome back to algebra. Let's talk about the properties of real numbers. They're way better than those fake numbers. Alright, anyway, here's what you need to know. There are some relationships between real numbers that are always true. Those are called properties. We can use these properties to rewrite and compare expressions. That's what we do when we're solving equations. Two algebraic expressions, we call them equivalent expressions if they have the same value for all values of the variable. So that means no matter what number you plug in for the variables, they're always equal. So following properties are expressions that are equivalent for all real numbers. So A, B, and C can be any real numbers. Now these are the commutative properties. Commutative property of addition. So commutative means you can change the order. Okay? 2 plus 3 is the same thing as 3 plus 2. They're both 5, right? So it doesn't matter what order you add in. So the commutative property of addition for any real numbers A and B, A plus B equals B plus A. For multiplication, A times B equals B times A. And here's some examples. 12 times a half is 6. A half times 12 is 6. They're both 6. Doesn't matter what order you multiply in. Then we've got associative properties. Associative properties is grouping. It doesn't matter if we do A plus B and then add C, or if we do B plus C first and then add A. We're adding all the same three things. It doesn't matter which ones we group together. Same thing with multiplication. So if you look at it here, 23 plus 9 is 32. And then on this side, 23 plus, let's see, 9 plus 4 is 13. 32 plus 4 is 36. And 23 plus 13 is 36. So they're equal. Same thing is going to happen down here with multiplication. So you can group things. You can change the grouping if everything is multiplication or if everything's addition. You can change the grouping. And that's the associative property. One way to remember that is here the B is associated with the A, and then over here the B is associated with the C. Associative property. You're welcome. Some more properties. We've got the identity properties of addition and multiplication. So identity means that you're going to do something to the number and get the same number back. So for addition, the identity is 0. Any number plus 0 is the same number. That's the identity property of addition. The identity for multiplication is 1 because any number times 1 equals itself. So those are the identity properties of addition and multiplication. Then we've got the zero property of multiplication, sometimes called the zero product property. The product of A and 0 is 0. So anything you multiply by 0 equals 0. I think you already knew that though. And the multiplication property of -1. So the product of -1 and any number is just the opposite of that number. -1 times A is the opposite of A, right? Negative A. Boom. So what property is illustrated here? 42 times 0 equals 0. Well, that's the zero property of multiplication because we multiplied something by 0 and got 0. What about here? B. Y plus 2.5 in a group plus 28. And then over here, y plus, then 2.5 plus 28 is in a group. The order didn't change. It's still y, then 2.5, then 28, y, then 2.5, then 28. Only the parentheses moved. That is the associative property because here we're associating these two in the same order, but over here we're associating these two. The associative property of addition because we're adding. How about this one? 10x plus 0 equals 10x. Well, I got the same thing back because I added the identity. So this is the identity property of addition. Now, what property is illustrated by each one of these statements? Why don't you pause and see if you can figure it out? Then push play and I'll tell you the answer. Did you really pause it? I hope you did. All right, what property tells us that 4x times 1 equals 4x? That is the identity property of what multiplication? How about over here? X plus square root of y plus z equals x plus z plus square root of y. Now you might see parentheses and say, oh yeah, that's the associative property. Associative property is about parentheses. But we didn't change what the square root of y was associated with, didn't we? Square root of y plus z in the parentheses, and it's still square root of y plus z in parentheses. What really changed is the order. The z and the y got flip-flopped, and that is the commutative property of, we're adding, so addition. Ooh, properties for mental calculations. A movie ticket costs $7.75. A drink costs $2.40. Popcorn costs $1.25. What movies are you going to where popcorn only costs $1.25? Seriously? This is not true. It's more like $10.25 for popcorn. Seriously, come on. Authors and their nonsensical price points in math problems. Goodness gracious. Okay, we're going to use mental math. And we're going to use some of these properties because wouldn't it be just so nice to add 7.75 and 1.25? Because I know that 25 cents plus 75 cents is $1. But we didn't list them in that order. If there was only a way that we could change the order that these were added in. There is a way. It's called the commutative property. I'm going to switch the order here, but the commutative property of addition. Unfortunately, the 7.75 is still grouped up with this $2.40. I still am adding these together before I add the 125. If there was only some way that I could group the 775 with the 125. I've got it. The associative property of addition. I can say I'd rather associate the 775 with this 125 rather than with the $2.40. So that's the associative property of addition. Well, now I got what I wanted. I got the 775 and the 125 inside the parentheses, so I can simplify that inside the parentheses. I know that 7 plus 1 is 8, and then 75 cents and 25 cents is another $1. That makes 9. So 240 plus 9, and what did we do there? We simplified inside the parentheses. Now all I got to do is add. 2 plus 9 is 11, so that's $11.40. Man, that's a cheap date. Way to go. Let me know what movie theater that's at so I can take my wife there. Yay! Why don't you pause and then see if you can figure this one out. Okay, did you get as confused as I did? Whenever I get confused, I have to stop and draw a picture. Alright, a can holds 3 tennis balls. So I'm going to draw a can with 3 tennis balls in it. A box holds 4 cans. So here's a box that has 4 cans of tennis balls in it. Alright, a case holds 6 boxes. There's a case with 6 boxes in it. Why am I doing this? Because, let's see, how many tennis balls are in 10 cases? 10 cases. Alright, so I'm going to do 10 cases times 6 boxes per case times 4 cans per box times 3 balls times 3 balls per can. And let's see, is there a good way to use any properties here? Well, I can use the associative property to group like this and like this. 10 times 6 is 60. 4 times 3 is 12. And then 60 times 12 is, let's see, 60 times 10 is 600. And then 60 times 2 is 120. So if I add those together, I get 720 balls. So that was my mental math. Not that I don't trust my brain, but just to check, let's multiply. 10 cases times 6 boxes per case times 4 cans per box times 3 balls per can, 720. Woohoo! Winner. Ooh, simplify each expression. Alright, so 5 times 3n. This is multiplication. 5 times 3 times n. So I can use the associative property to group the 5 and the 3 together. Alright, 5 times 3. So I use the associative property of multiplication, and now 5 times 3 is 15. So 15n. And I got that by doing what we call simplify. Okily dokily. B. 4 plus 7b plus 8. Gee, I'd like to get the 4 and the 8 near each other. Hey, I could use the commutative property and switch the order of the 4 and the 7b. That's the commutative property of addition. Then, if I can group like this using the associative property of addition, then I can simplify inside the parentheses. And now this is the expression I'm done with. I can't add these two together. 7b's plus 12. Yeah, I'm not allowed to say like 19b, because that's not true. That would be 7b plus 12b. All you gotta do is just stop. These are not like terms. You cannot combine them. Okily dokily. 6xy over y. I can rewrite the denominator using the identity property of multiplication. So here's the denominator. I know that y is 1 times y. That's the identity property of multiplication. Now this is the rule for multiplying fractions. The rule for multiplying fractions, top times top equals top, bottom times bottom equals the bottom. So I had one fraction here, which was like top times the top, and bottom times the bottom. I can break it apart into two fractions. So how do I know? Let's see. X divided by 1, or 6x divided by 1 is 6x, and y divided by y is 1. So 6x over 1 is 6x, and y over y is 1. Then I can use the identity property of multiplication to say that that is 6x times 1 is 6x. Alright, pause and simplify. Then push play when you got them. Let's do this. Okay, 2.1 times 4.5 times x. So I'm going to use the associative property to group the two decimal numbers together. And then I'm going to simplify inside. 2.1 times 4.5, 9.45. So this is 9.45x. Okily dokily, how about this? I can use the commutative property to switch the order of these two. And then I can use the associative property to group the 6 and the 3. 6 plus 3 is 9. So I got 9 plus 4h. These aren't like terms, so I can't combine them. Alright, let's see. How can we attack this problem? 8 times m over 12 times m times n. Well, the commutative property says I can switch these two. So 12 times n times m. And then I can use the rule of multiplying fractions to call this 8 times m over 12n times m. I can break apart into the product of two fractions. 8 over 12n times m over m. M divided by m is 1, so I get 8 over 12n times 1. The identity property of multiplication tells me that that's 8 over 12n. A lot of this stuff you might be used to doing in your head, but I'm just showing you what these properties are that you're really using. Now I know that 8 is 2 times 4, and I know that 12 is 3 times 4. I can use the associative property to switch the order of these two. Commutative property. The commutative property moves things. 3 times n times 4. Then the rule of fraction multiplication. 2 over 3n times 4 over 4. 4 divided by 4 is 1. So this is 2 over 3n times 1. And the identity property of multiplication says that this is 2 over 3n. And there's nothing else I can do because 2 over 3 doesn't simplify, and there's no other n's to divide out. So we're donezo. Also, the secret phrase is ringy-dingy. Ringy-dingy. Let's look at problem 4. Is the statement true or false? If it is false, give a counterexample. For all real numbers a and b, a times b equals b plus a. Well, let's see. That doesn't sound like it should be true. Let's pick some numbers and see if we can get a counterexample. In order to prove it's false, we just have to give one counterexample because it says for all real numbers. So if we find two real numbers that it doesn't work for, then we say false. So let's pick, let's say a equals 5 and b equals 2. So that means that 5 times 2, does this equal 2 plus 5? 5 times 2 is 10. 2 plus 5 is 7. So this is our counterexample, and we say false. Or another way to say it is false. 5 times 3 does not equal 3 plus 5. 5 times 3 is 15. 3 plus 5 is 8. And those are not equal. For all real numbers a, b, and c, a plus b plus c equals b plus a plus c. Well, let's see. This looks like kind of like one of those properties, but not exactly, huh? So here's what we're going to do. We're going to see. It looks like it could be true. And if we can get from here and then just change it using the properties we know and end up here, then it's true for all real numbers. So here's where we're starting. We're starting with a plus b plus c. Then we're going to use the commutative property to flip these two. See, a plus b has now become b plus a. Then we'll use the associative property to group the a and the c. And that got us over here. So this one is true for all real numbers because we used two properties that we know are true for all real numbers. So why don't you pause and give this some thought. See if you can get an answer for those. Alright, so A. For all real numbers j and k, does j times k equal k plus 0 times j? Well, let's see. K plus 0 is just k, right? And k times j should be the same as j times k. So let's see if we can start with j times k and just use properties to get k plus 0 times j. Alright, so j times k is equal to, I can use the commutative property of multiplication to say that this equals k times j. And now k times j, I can use the identity property of addition to say that k is equal to k plus 0. And there I am. Alright, B. So that's true. True! A is true! For all real numbers m and n, m times the quantity n plus 1 is equal to m times n plus 1. Well, if you know the distributive property, which we technically haven't learned yet, but you've probably seen it in pre-algebra, or Math 8, or Math 7, one of those, the distributive property says we should get multiplied by both parts inside here. So I think this is going to be false. So what I'm going to do is I'm going to pick two numbers for m and n. So I'm going to say, let's let m equal 3, and let's let n equal 2, and just see if that works. So we got m times n plus 1, and we want to know if that is equal to m times n plus 1. We're going to substitute a 3 for m and a 2 for n. And then same thing over here. 3 times 2 plus 1. So inside the parentheses, 2 plus 1 is 3. 3 times 2 is 6 plus 1. 3 times 3 is 9. 6 plus 1 is 7. There's our counterexample. And then C. Is the statement in part A of problem 4 false? So that's this. Is this false for all real numbers? For every pair of real numbers A and B? So the question is, can we figure out two numbers that this works for? And I can think of one, but A and B would have to be the same number. That is possible. It does. There's nothing that says that A and B have to be different numbers. So I know that 2 times 2 is the same as 2 plus 2. They both equal 4. That's one of those magical relationships. So no, because 2 times 2 is the same as 2 plus 2. It's not false for every pair of real numbers. It's not false for this pair. Well, I hope you had fun learning about properties of real numbers. I'll see you on the next video. Go ahead and do the 1.4 practice and the 1.4 formal write-up. Talk to you later.